All right, ladies and gentlemen, here we go. Check it out.
Because today we're looking at an absolute game changer in how we handle edge AI. We're talking about ShelfCat. This system is completely shattering the old clunky edge AI paradigms. We're going to break down its Rust-based version 4 architecture, and this is the best part, we'll explore our brilliant, completely hype-free business playbook for actually getting infrastructure like this out into the real world. So here's our roadmap for today. We'll hit the edge AI problem first, then ShelfCat v4 slot gating, how semantic gating actually works, this concept of a pre-language for AI, the open core strategy, and finally wrap it up with a clean exit. All right, part one, the edge AI problem and why the raw data to cloud model is totally flawed. To really get why ShelfCat is so valuable, you have to look at what everybody else is doing. Right now, most AI systems use a really brute force pipeline. I mean, they capture raw perception data, literally millions of pixels, and just blindly pipe it straight up to the cloud for a model to process and spit out an answer. The problem? Well, it wastes massive amounts of bandwidth and creates terrible latency. But honestly, the worst part is the ambiguous meaning. When you have multi-agent systems, they end up failing because they lack shared physical contracts. Basically, the models don't understand the physical rules of the world they are observing. They're just talking past each other with different embeddings, completely lacking any structural grounding. You can see the contrast right here. Traditional GPU-first pipelines, like your standard NVIDIA or GCP stacks, they're great at inference, sure, but they are awful at data governance. Their whole philosophy is just more GPU is better. But ShelfCat completely flips the script. By operating right there at the edge with a really lean Rust backend, it undercuts cost, energy, and latency without losing an ounce of accuracy. And how does it pull that off? By sending validated facts instead of raw pixels. It enforces semantic consistency way before that data ever even sniffs a cloud model. Moving into part two, ShelfCat v4 slot gating, an iterated production-grade system. Now, ShelfCat didn't just appear out of nowhere. It's not some weekend prototype. It is a multi-version, battle-tested computer vision pipeline. Looking at its evolution is actually really fascinating. Version 1 was pretty standard, just capture, upload, and run some CV inference. Version 2 added image shrinking and batching. Then, version 3 introduced Rust ingestion and validation. But version 4 is where the magic really happens. They brought in slot gating and planogram-aware enforcement. This means the AI actually knows the physical blueprint of how products are supposed to sit on a shelf. At this point, ShelfCat is no longer just doing inference, it is actively governing data. And let me tell you, that data governance, that is the ultimate technical moat. This creates a highly defensible reality. Competitors can't just quickly copy this. Why? Because of the domain-specific gating logic, that hyper-efficient Rust and zero-copy architecture, and all the hard-won production knowledge baked into the system over 4 real-world iterations. You're literally deciding if a costly inference is even allowed to happen before paying the computational toll. It's brilliant. Which brings us to part 3, how semantic gating works, or as I like to call it, structure before intelligence. Let's look exactly at how it achieves this. This isn't just basic image shrinking, folks. This 4-step pipeline executes semantic, load-bearing compression. First, it normalizes the perception, shrinking it down to a model-relevant resolution and stripping out the noise. Second, it applies shared geometry and rules, like shelf geometry and slot expectations. Third, it gates the semantics. It literally asks, is this frame valid? Does it violate physical constraints? And finally, step 4, it emits constrained, meaningful signals. So instead of dumping a huge raw image file, it outputs a bounded uncertainty, something crisp like slot 4, skew X, confidence 0.92. On to part 4, a pre-language for AI, and the shared ontology for multi-agent systems. Emitting structured facts like that entirely changes how downstream AI components interact. Think about it like this. Just as we humans rely on grammar to actually understand each other, ShelfCat acts as a pre-language layer for AI. It gives the AI grounded observations, shared rules, and compact messages. Because every AI component downstream is now speaking the exact same ontology, the same shared vocabulary and rulebook, it dramatically cuts down on hallucinations, stops cascading inference errors in their tracks, and prevents models from making claims that literally defy physics. This completely unlocks edge-to-edge communication. Let's say Edge Camera A registers that a slot is empty. Well, Edge Agent B doesn't actually need to process the raw image to believe it. It simply trusts the gated semantic signal. It trusts the fact. This right here is exactly how distributed intelligence actually scales in the real world, without just collapsing under its own massive data weight. Okay, pivoting a bit for part 5, the open core strategy. It's all about building trust and widespread adoption. So, stepping back from the incredible technical architecture for a second, we have a very practical business question to answer. How do you actually get this infrastructure into the hands of the staff engineers and robotics teams who desperately need it? The source material outlines this brilliant open core playbook. The strategy is to open source the foundational stuff, the Rust ingestion, the gating logic, the schemas. You give away that core logic so builders can easily adopt it and trust it. But you hold on to the advanced tooling, the enterprise support, and the hosted services. That's how you ensure you've got a sustainable business where the big institutional stewards are the ones actually paying you.
And you definitely don't just pitch this to everyone. You target 3 very specific audiences in order. First, it starts